The student therapy, physical therapy student data collection experience. Hi, I'm Tim Richardson. This is an app designed to virtualize the Foam-and-Dome. As a physical therapy student, you learn this in PT school. The clinical test of sensory integration and balance has been developed, is developed, works. I'm going to take you through it right now. We are looking for student data collectors. If you can collect 1 test, 5 tests, 10 tests, each test is 3 minutes. You can test yourself, your peers, your roommates, your boyfriend or girlfriend, your family members. All of this contributes to the validation of the app, the CTSIB test in the app. Let me walk you through it. The name of the app, it's on the Apple App Store. It's called the VisualPT.ai. You can see it down there in the lower left, and it's on the website at VisualPT.ai. Let me walk you through it right now. Okay, as soon as I figure out how, there we go. So those of you will remember from PT school, condition 1, eyes open, firm surface. Here she is standing, her feet together. We do have instructions and a workbook, but you guys probably remember this. Feet together, arms crossed, standing straight. She's within the bounding box, so this is the 8 degrees. It's a slight angle to either side. This is normal trunk sway, normal variation. So she is within the trunk sway. Once we take the test, we go through this validation process down here at the bottom, and I'll talk to you about that here in just a minute. Okay, so condition 1, eyes are open. You can't really see because of the vector lines, but her eyes are open. She is on a firm surface. Okay, let me show you the next. So if she takes a step, if she sways outside of the bounding box or uncrosses her arms, one of these validation conditions are activated. And this is an example where she took a step. You can see that now her foot is outside the bounding box. Still condition 1, and we will, on validation, after the test is over, we'll toggle foot. And we're telling the AI, we're saying to the AI, hey, this is a failure condition. This is a fall. This patient has fallen down, or the test is, she's exceeded the limits of stability. That's what that bounding box is, the limits of stability. Okay. All right. Condition 2, eyes closed. Or now it's eyes closed, still on a firm surface. So this is condition 2 of the CTSIB. And then now she's taken her step forward. You can see how the vector lines here are not even. She's outside of the bounding box, and so this does activate the what we call the failure condition, or this would be classified as a fall. And we're saying, well, this fall is because the foot moved. Okay, and these are the same decisions a physical therapist would make when doing the pen and paper CTSIB, or these are the same even if you were doing a Burtec or a the older one, Neurocom, the Neurocom. You would still be making these decisions. These angles would be quantified on the force plate. We're quantifying them with these vector angles that you'll see when we print out the test at the end. Okay, so condition 2, eyes closed, firm surface. She swayed or fell. Condition 3, now she's got the visual conflict. It's called the Foam-and-Dome, otherwise known as the CTSIB. If you're using one of the big machines like a Burtec or a Neurocom, it's called the Sensory Organization Test, or the SOT. So I learned it back in 1992 as the Foam-and-Dome. You can use a hat, you can use a baseball cap, basically anything that will create visual conflict. So her eyes are open, but she cannot see the horizon. She's not receiving environmental stimulus as to her head position in space, head and body position in space. So visual conflict, firm surface, and again, there's the failure condition, and we circle the foot. Okay, so that you can see how this is pretty consistent here. Let's get to condition 4. Now her eyes are open, and now she's on the foam surface or an unstable surface. same kind of decision-making process. Now she's stepped backwards. Even though she's still within the bounding box, you can clearly see that the leg vectors are asymmetric, and so she's stepped backwards. And again, we're going to click. The therapist is what we call the validator. So once the test is completed, we'll go through each and every image. There's you can see there's quite a few images. I think there's 300 images per test, 320, something like that. So it's 2 images per second, 30 seconds per condition, 6 conditions per test. So I think it's like 360 actually. So the physical therapist goes through each image, and I just selected these screenshots to show you the sequence of the test and the types of decisions the student validator will take. Okay, and we are training the AI so that in the future the AI will do all this for you. You won't have to do this. We'll just have to capture the video. So condition 5, eyes closed, unstable surface. Okay, and there again she steps backwards, and so it is the foot, not the trunk, and not the arm that is triggering the fall condition. Okay, last condition, visual conflict, unstable surface, again using a hat or a dome. And then in this condition, looks like I've put the circle in the wrong place. This would actually be, even though it's out, that's a judgment call. This is why we still need human validators. I might call that one static or stable. It looks like somebody included that as an example of a sway condition. Okay, so you can see this is a great example why we need human validators. So 2 humans might disagree, and then that's why we need lots and lots of data, because this is what's called the inter-rater reliability of this particular method of capturing CTSIB data, CTSIB data. The pen and paper method does have a very high inter-rater reliability, and we're looking to capture good data so that this virtual mobile device camera computer vision version will also have good inter-rater reliability. Okay, and then this is the printout. This is all the data. So these are the 6 conditions, and the surfaces, the vision. There's your lateral sway to one side or the other, your longitudinal sway, and then there should be a equilibrium score. All of the time trials, we let them go to their max even though the patient fell. Again, in a patient condition, you would be stopping the test as soon as they took that step with their foot. So this is how the VisualPT.ai mobile device measures the CTSIB test. Hope that was helpful. Thanks for watching.